In this next example, I've adapted my doubly linked list so that I can use it as a queue. There are other ways of programming queues, but this is quite a convenient way of doing it. Now, this time I've defined a struct especially for the list header and a different struct for the list elements. The 2 pointers of the list header struct have been given the names first and last for clarity. As before, these 2 pointers let us quickly get at the elements at both ends of the list. The 2 really important new features of this code, however, are my enqueue and dequeue functions. And we can see these down here. Enqueue is used to add a new item to the back of the queue, and dequeue is used to remove an item from the front of the queue. Think of the queue like this. The queue itself is a list of elements, and I keep pointers to the first element and the last element of the list. Now, when I have a new element that I want to add to the list, I add it to the end of the queue. That is called enqueuing, and this now becomes the last element. When I want to take an item from the list, I take the first item, the item at the start of the queue, and that's called dequeuing. So this is a bit like a line of people waiting to go into a theatre or a cinema. Person 0 is the first person to arrive. So person 0 is at the beginning of the line, that is, at the beginning of the queue. Person 4 is the last to arrive and so goes to the end of the queue. And when another person arrives, person 5, they go to the end of the queue. And when the doors are opened and people start to go into the theatre, the person at the beginning of the queue, that's person 0, goes first. In programming jargon, person 0 is dequeued. Meanwhile, another person, person 6, arrives and is added to the end of the queue, and in the jargon, they are enqueued. Now, I don't plan to go over the code in this program in the same minute detail as when I explained doubly linked lists. If you followed that tutorial, you should be able to work out what is going on by loading and running the queue code project yourself. But just look at this enqueue function. That goes to the end of the list with the help of the head last pointer. It adds a new item to the end of the list, assigns the new item's next pointer to head, and the prev pointer to head last, which is the previous element in the queue. The end result is that the new item is put at the back of the queue. The dequeue function does exactly the opposite. It gets the element at the front of the queue using head first, removes it and returns it, and adjusts the pointers so that the new head first pointer points to the new first item, that is the one following the item that had just been dequeued. And here is the main function. If you look at that, and you can see that the element that was returned by dequeue is tested to ensure that it's a valid struct. And here it would be null if it isn't, because that is what dequeue will return in that case. That is, if there is nothing left in the queue. If the struct is not null, I just print out its data and then free its memory. So when I run this program, you can see the results here. The queue is created, enqueued, with the struct containing 0 first and the struct containing 2 last. And when it's dequeued, that order is maintained. The first in, 0, is the first out.